Up until now, we've worked out derivatives using first principles or the definition. There are some that you need to know just off by heart and commit them to memory. And I'll make up a little table of those as we work through, and I'll give you some examples. So if we've got a function of x, you need to be able to write down straight away what the derivative is. So all of these can be proved using the definition and going through the method that I've done in previous videos. So let's just have a look at these. So if we've got a function and it's a and n are constants, so you've got a number here and a number in the power there, so x to a power and y is a function of x, then the derivative is n times a x to the n minus 1. You take one off the power, but before you do that, you bring the power down to the front. So the n comes to the front, and then you take one off the power. Once again, if you wanted to do that by first derivative from first principles rather, you can do that. So if we had y equals, so as an example, 3x to the 5, then dy dx is equal to, now using our rule, whatever the power is comes to the front, so it'll be 5 times 3 x, and you take one off the power, so 5 minus 1. Now most of you won't write that, you'll just go straight to the answer. 5 times 3 is 15, x, 5 minus 1 is 4. Alright, so that's how to do that one. Next one, if you've got the exponential number with an x up there, but once again a and n are constants, and it's a little bit different of this. You don't take one off the power. The n comes down the front, and you've got e, and you've still got the same power as you had before. So if y equals 2e to the 5x, then dy dx, I won't do that intermediate step as I did up here. The 5 comes down, 5 times the coefficient, 5 times 2 is 10, e, and it stays as the same power, so it'll be just to the 5x. So that one, those two you need to know off by heart. Number 3, derivative of sine x is cos x. Well, no point in giving you an example of that, but what I will say is that x has to be in radians, not in degrees. X has to be in radians for the derivative of sine x equals cos x. And so the derivative of cos x is negative sine x, so you go from sine to cos, from cos to negative sine, and x once again has to be in radians. The derivative of tan x is sec squared x. Now sec is 1 on cos, or secant is 1 on cos. So sec squared is 1 on cos squared. Same thing, x has to be in radians. This is a bit different. The natural log, or log to base e, the derivative of that is 1 on x. And there's not really any point at, well, let's just say if y equals ln x, then dy dx equals 1 on x. Okay. And there are a number now of other trig ratios. So we've got the inverse tan function. So we've got y is equal to inverse tan x. Well, dy dx is 1 over x squared plus 1. If y is equal to the inverse sine of x, then it's 1 over the square root of 1 minus x squared is the derivative. We came across sine and cosh. So the derivative of sine x is cosh x. And unlike these up here where you go sine, cos, negative sine, with these functions here you do not put the negative in. So derivative of sine is cosh and the derivative of cosh is sine. Once again x in radians.